My name is Matsia, and I will present you the research that we have been doing on structural bioreactivity correlations in binary thallium hydroxycarboxylic acid systems. The outline of the presentation is the following: an introduction to metallotoxins and their role in pathophysiology, the scope and the research goals, the design and synthesis of thallium-based materials, as well as their physicochemical profile, the biology and tissue-specific environment, and finally the conclusions. The metallotoxins are increasing worldwide in the environment, thus affecting the human body. This work is based on thallium heavy metal, not only from the fact that it is a metallotoxin, but due to its importance in different biomedical applications as tissue mapping or perfusion imaging. So based on what I have mentioned, the scope of this research is to comprehend the role of metallotoxins in cellular media. Based on that, the research goals include the design and synthesis of thallium-based materials in aqueous media and in vitro and in vivo studies. To do that, we started from the design of such materials, and here you can see the selected alpha hydroxycarboxylic acids, glycolic, lactic, mandelic, and citric acid. All the binary systems of thallium-based materials were fully characterized in solid state and in solution through FTIR, ESIMS, proton carbon NMR, and X-ray crystallography. Here you can see natural speciation of the materials with the one starting from the glycolic acid, the lactic acid, and the other substrates with mandelic and citric acid, with their 1D, 2D, or 3D lattice architecture of the crystalline coordination polymers. The biological investigation of all well-defined and isolated species were investigated in 4 different cell lines. Here you can see some examples of the 3T3L1 and the SAUS2 cell lines, and the results in all the lines shows that for longer incubation times, 48 hours, a significant decrease in cell viability was observed. The most important point is that the more bioavailable a structure is, the more toxic it is, and this is for the one of thallium citric acid binary system. Further work of this research include the investigation of the toxicity of such compounds in intracellular communication with emphasis to connexin biology. To conclude, we have designed and synthesized binary thallium hydroxycarboxylic acid systems, fully characterized and isolated. And the thallium species reveal new aspects of metal ion toxicity at molecular level. I want to acknowledge all the collaborators of our lab. I want to thank you all for your attention.